Hello friends, welcome to C programming video tutorial series. From the past few video tutorials we are trying to understand tokens of C programming language. In the previous video tutorials we have discussed comments and keywords. From this video tutorial onwards, for the next few video tutorial I would like to discuss data types in C language. What is a data type? The name itself indicating data type means type of data. Data type indicates type of data. While developing any software application, we will be dealing with different types of data. We will be processing different types of data. For example, if we are building a game, then we need to keep track of player score, right? Player score will be in the beginning 0, later it becomes 10, 20, 100. We need to set the gravity of the world. We need to check whether the player wants to replay or not. One more example I give. If we are building a banking application, then we need to generate account number. We need to set the rate of interest. We need to check whether the account holder has loan or not. You can see here that player score has the value 10. 10 is an integer type of data. Integer numbers are whole numbers. Numbers without floating point are called as integer numbers or whole numbers. Here, as player score has an integer number, player score is of integer type of data. Gravity 9.8. 9.8 is of real type of data. Numbers with decimal point or floating point are called as real numbers. As gravity has a floating point number, gravity is a real type of data. Replay is of character type of data. A symbol enclosed in between single quotations is called as a character in C language. So replay is a character type of data. If you see the banking applications example, account number is an integer type of data. It is holding a number without decimal point. Rate of interest is a real type of data. It is holding a floating point number or a fractional number, number with a decimal point or a floating point. Has loan is a character type of data. So while developing software application, we will be dealing with different types of data. We need to store different type of data. We need to process different types of data and get the information out of. To store different types of data, C provides two different types of data types. Types of data types. There are two types of data types in C, primitive and non-primitive. We take help of primitive and non-primitive data types to store, process different types of data, friends. Primitive data types are also called as basic data types or built-in data types. Non-primitive data types are also called as derived types or composite types or complex types. Non-primitive data types are derived from primitive data types. Hence, non-primitive data types are also called as derived data types. Non-primitive data types are composed of primitive data types. Hence, non-primitive data types are also called as composite data types. As non-primitive data types are composed from primitive data types, you can also call them as complex data types. User-defined data types are also part of non-primitive data types. Let's discuss primitive data types in detail. Int, float, double, char, void are primitive data types. There are 5 different primitive data types we have in C language. Int indicates integer numbers or whole numbers, numbers without floating point. For example, 22 minus 44 2017 are examples for integer numbers or whole numbers. You can see that these numbers don't have decimal point or floating point. Numbers which have decimal point or floating point are called as real numbers. There are two different types of real numbers we have, float and double. Float data type indicates single precision real numbers, whereas double indicates double precision real numbers. If you observe the examples of float and double data type values, both have decimal point or floating point. What is the difference between float and double then? The difference is the precision. Float can store 6 to 7 digits after the decimal point, whereas double can store 15 to 16 digits after the decimal point. So double help you to get more accurate results. For example, if you are building a scientific applications or physics based applications, there you need accurate results, more accuracy. If you consider more accuracy, then create a variable or a constant of type double. Whereas if accuracy is not much important, then you can create a variable or a constant of type float. If you create a variable or a constant of float, that variable can hold a number containing 6 digits after the decimal point, or 6 to 7 digits after the decimal point. That depends upon the compiler again. Okay. If you create a variable or a constant of type double, that variable or a constant can hold a number containing 15 to 16 digits after the decimal point, more accurate. Also, the real numbers we can represent in two different forms, two different notations we say. One is decimal notation, or we say fixed notation. Another one is scientific notation or mantissa exponent notation. Scientific notation or mantissa exponent notation. Let me explain how to convert a scientific notation floating point number to a decimal form, to the decimal form, and how to convert a decimal form floating point number to a scientific notation number. Let's see that. I go to here MS Paint. For example, if I write here 2.1 E plus 8, if there is a scientific number, we have 2.1 E plus 8, how do you convert this to a decimal fixed form number? You need to write like this: 2.1 E is there you need to write multiply, plus 8 is there, you need to write 10 raised to the power of plus 8. Okay, then you need to evaluate this expression. If you evaluate this expression, what you get, let me take calculator. 10 raised to the power of 8 is equal to this much, multiplied by 2.1 is equal to this much. So 21, 1, 2, 3, 4, 5, 6, 7 zeros. All I need is 21, 1, 2, 3, 4, 5, 6, 7. So this is the decimal form or a real number of the scientific notation. We have converted from the scientific notation to a decimal form or a fixed form notation. It's quite simple, right? How to convert. If you want to convert this again back to this notation, same steps you need to follow. All you need is, you can think like you have the decimal point here at the end with extra 0. You are going to move this decimal point or float this decimal point after the 2 here. So how many positions you need to move? 1, 2, 3, 4, 5, 6, 7, 8 positions. So 2.1 multiplied by 10 raised to the power of plus 8 you need to write. If you are moving the decimal point from right to left, you need to use plus sign. And then you need to write 2.1, then you need to write E, then plus 8. You need not write 10 there. Now this part before the E is called as mantissa part, and this part after the E is called as exponent part. This is mantissa exponent notation or scientific notation of this number, friends. When the number is too big or too small, we or computer represent that in scientific notation or mantissa or exponent notation. I hope you guys have clearly understood how to convert a scientific notation number to a decimal notation, vice versa. Okay, if you want, I can give you one more example. For example, if I say here 2.1 E minus 8, how do you represent this now? 2.1 E minus 8, this time we have minus. We can convert very easily. All I need is, I need to write 2.1, E is there, multiplied by 10 raised to the power of minus 8 we have to use, raised to the power of minus 8. Now I take the help of calculator again to evaluate that expression. So I say clear. I say 10 raised to the power of bracket minus 8 bracket close is equal to this much, and then I'm going to multiply it by 2.1 is equal to, this is the value. We have 0 point, after that 1 2 3 4 5 6 7 zeros, then 21. So here I write 0.1 2 3 4 5 6 7, then 21. Now we have converted scientific to real or decimal form. We can convert this back to the scientific notation. How? All you need is how many digits or positions you need to move this floating point or decimal point. 1 2 3 4 5 6 7 8. So you need to write 2.1 multiplied by 10 raised to the power of minus 8 you have to use if you are floating the decimal point or a floating point from left to right. And then you need to write 2.1 e minus 8. This part is a mantissa part, this part is an exponent part. Now we have converted a decimal number to a scientific notation, and I hope you guys have understood the difference between the decimal form and scientific notation. Next we have char type. Char indicates any symbol from the ASCII chart enclosed in between single quotes. For example, A we have sandwiched in between single quotes. This is a character. 9, even though it is a digit, as we have enclosed it or sandwiched in between single quotations, it is a character. /n is a character. /t is a character. /n indicates line feed, enter key. I discussed /n in the previous video tutorials. /t indicates the tab key or tab character. Void indicates no value, or simply we say nothing. Void, using the void we don't create any variables or constants. We use it as a return type for functions. I discuss it later. Okay. And also I want you to remember these format specifiers. For integer we use format specifier either %d or %i. We use this format specifier while getting the input and displaying some output on the screen. If I need to get the integer number from the keyboard, or if I want to display an integer number to the console, I'm going to use %d or %i. For float we use %f if it is a real number or a decimal form. If it is in the exponent form, we take help of %e. So we use either %f or %e. %lf for double, or we can say long float, and %c for character. These format specifiers I suggest you people to remember, because we are going to use them while getting the input and displaying the output. If I want to display an integer number, I am going to take help of %i. If I need to display a float number or get the float number from the user, I take help of %f format specifier. If I need to display a character or get the character from the user, I am going to use %c format specifier. We are going to see the demonstration anyhow. You get the clear idea. Let's have a small demonstration and understand how we use this format specifier, why they are required, and we understand some of the points with respect to integer, float, double, char. I minimize MS Word, minimize MS Paint. I double click on the code block shortcut to launch the code blocks IDE. You can see that the code blocks IDE got launched. I'm going to create one new project by going to File, say New, click on the project. I select Projects, Console Application, say Go. Say Next. I select C language, say Next. I give the project title here, Data Types Demo. Then I say Next, say Finish. I click on plus sign, I double click on main.c. I'm going to zoom this content a little bit more. Okay. I'm going to select this, say delete. I don't want that line of code. We know that the printf function is going to display this hello world exclamation mark on the console, and it moves the cursor to the next line. If I say build and run, we see the hello world exclamation mark. I hit enter. We know that the printf function is going to accept sequence of characters enclosed in double quotations. Const char star indicates sequence of characters enclosed in double quotations. Here I say Manjunath. Also we have comma and 3 dots here. 3 dots that indicates additional arguments, right? Variable length arguments. If we want, we can pass more arguments by giving comma here. At present, if I say just build and run, we see Manjunath displayed there, right? I hit enter. I also want to display Chidre. So what I do here, I give comma, in double quotations I say space Chidre, double quotations, and I also use /n for the new line character. When I say build and run, you see that the system is displaying only Manjunath. It is not displaying Chidre. The printf function only displays the first argument, the first parameter. It just displays each characters from left to right. It displays MANJUNATH on the console. It is not going to display the additional arguments. How do I display these additional arguments now? As I told, printf only displays the first argument. How do I display these additional arguments? As this argument that I have passed, additional argument, is enclosed in between double quotations. This is a string, right? Sequence of characters enclosed in double quotations is called as a string in the C language. What I do here, in the first argument or a parameter, I just give %s. %s indicates string format specifier. This is a format specifier used for displaying strings. This is actually a placeholder for the string. What happens when I build and run means the printf function is going to display MANJUNATH. Once it finds %s, what it does is it takes the first argument available in the additional arguments list or variable length argument list, that is a string Chidre and /n. In this place, it replaces this argument. It is going to put here space Chidre /n. That is going to be the final printf statement. Let me remove that and say here %c, %s. When I say build and run, this time you say Manjunath Chidre is displayed. What is happening, you can understand. Printf is displaying MANJUNATH. %s is going to be the first argument in the additional argument list. Space CHIDRE, then /n is going to move the cursor to the next line. That is the use of format specifiers, friends. We can take help of format specifiers to display additional arguments to the output. Also, we use that while getting the input. We discuss how to get input and how to display outputs more in detail later. At present, I just want to give you a brief information about format specifiers, how they are useful. Let's take more example, okay? I just go here and I say here printf. This time I say here a string, the sum of 2 and 2 is equal to, then I give comma 2 plus 2 at the end, semicolon. As I told that the printf function is going to display only the first argument. It is not going to display any additional arguments. It displays the sum of 2 and 2 is equal to and /n. If I say build and run, you see that it is displaying the sum of 2 and 2 is equal to. We don't see here 4. 2 plus 2 is 4, right? It should display 4. How do I display that 4 on the screen? To display that 4, we need to take help of format specifier. I take here %i. %i is for integers we use. What happens here in the code blocks now? When I say build and run, the system displays the sum of 2 and 2 is equal to. %i is going to work like a placeholder for an integer number. In this place, it displays the first argument in the argument list, that is 2 plus 2 is 4. It displays here 4 and then /n will be executed. If I say build and run, now you see the sum of 2 and 2 is 4. Can you see that? That is how we use format specifiers. If I want here 2 and 2 also to be displayed, all I need is I'm going to write here 2 comma 2 comma. Now this time what happens, you should understand, if you have more than one arguments here in the additional argument list, what system does, as I told, it displays the sum of 2 and 2 is equal to percentage I is the placeholder for an integer number. What happens here, it takes the first argument in the additional argument list, and if it is an integer number, it puts in this place. If I say build and run, this time you see the sum of 2 and 2 is 2, not 4, because that is the first argument in the additional argument list. I want this 2 should be displayed here. Here I use percentage I. And this 2 should be displayed here. Here I use percentage I. Now what happens, when this printf gets executed, the system displays the sum of, as there is a percentage I, it goes to the additional argument list, takes the first argument, if it is an integer, displays that here, then displays space and space percentage I. It goes to the additional argument list, it takes the second argument from the argument list, it takes that, if it is an integer, displays here, then it says space is equal to, then percentage I, it goes to the additional argument list, takes the third argument, 2 plus 2 is 4, if it is an integer, it displays here, and then /n will be executed. If I say build and run, now you see the sum of 2 and 2 is 4, right? How much interesting it is. I hit enter. If I say here now 3 4 3 plus 4, if I say build and run, you see the output displayed there. The sum of percentage I is replaced by 3 and percentage I is replaced by 4 is equal to, third percentage I is replaced by the third argument in the additional argument list, 3 plus 4 is 7. That is how we use format specifiers. As I told that float is going to be a single precision real number and double is a double precision real number. We can see how many digits a float can store after the decimal point, how many digits a double can store after the decimal point. Let's see that. I go to code blocks. Here I say printf float precision, precision is equal to, here I use comma. First of all, I'm going to include hash include float.h. In this header file we have some constants to use. Here I say flt underscore dig float digits. This is an integer number, so here I write percentage I then /n. Float digit, if I right click and say go to declaration, find declaration of flt dig, so this is a place it is declared float.h. that is the reason I have included float.h here in the main.c. Now when I say build and run, okay, we have an error, that is we missed a semicolon. Now I say build and run, you can see the output displayed there, float precision is 6. So the system is displaying float precision is equal to percentage I is replaced by the value of flt underscore dig that is present in float.h, that is 6 actually. So it is displaying 6. Now I go back, hit enter. Let's see for the double now. I'm going to copy this line of code, hit enter. Now I say here double, double precision is percentage I. Here I replace this with dbl underscore dig. This is going to give us the double precision digits, how many digits the double can store. If I say build and run, you see that it is showing 15. That means float can store 6 digits after the decimal point, double can store 15 digits after the decimal point in code blocks. I hope you guys have clearly understood what is the meaning of data type, what are the different types of data types we have, primitive data types, okay, and the format specifiers, how we can use them. And also we have non-primitive data types like arrays. Array indicates list of data values. Pointer represents the reference of another memory location. Structure represents the record. Union also represents the record. For example, if you want to hold list of data values, we create arrays. If I need to store the address of Another memory location, we create pointers. If I need to create student records, I'm going to create a structure. We discuss non-primitive data types in detail later in upcoming video tutorials. I suggest you people to watch this video again and again. Understand clearly data types. In the next video tutorial, we are going to discuss some notes on data types. So for this video tutorial, this much is enough, friends. I hope you guys have clearly understood. I suggest you people to execute this code yourself. If you have any doubts, please post comments. For more benefits and be up to date, please subscribe to my YouTube channel. Don't forget to like, comment and share these videos with others so that everyone will get benefited. Keep learning, keep coding, keep sharing. Thank you guys. Thank you very much. See you in the next tutorial.